All right, so as I mentioned in the very brief introduction, a hash table is an abstract data type. So it doesn't dictate how you store the data. You can back a hash table with whatever you want. A hash table provides access to data using keys. So when it comes to hash tables, they consist of key value pairs. When you add an item, you provide the key and the value, and when you want to retrieve the item, you provide the key, and then from there, the hash table can retrieve the value, and it can do it really, really quickly. So hash tables are optimized for retrieval when you know the key, obviously. If you don't know the key, then retrieval is not going to be very fast. You can do it, but it's going to be slow. So when we're talking about arrays, we could see the array index as the key and the value is the element in the array. But for hash tables, the key doesn't have to be an integer. You can use whatever you want. You can use whatever type of object you want. Strings are a common data type that's used for keys. In fact, if you've worked with languages like PHP that have associative arrays, well, associative arrays are one type of hash table. And so in that case, you're using a string as the key into values in the array. Now, the key value pairs, the data types don't have to match. So as you'll see, we'll use a string as a key to retrieve employee objects. We're going to use the last name of the employee as the key. And so hash tables consist of key value pairs. They're optimized for retrieval, and they provide direct access to values in the table using keys. Now, another word for hash table, they're also known as dictionaries, maps. If you've ever used one of the map classes in Java, you're working with a hash table, lookup tables, and as I said, associative arrays. Okay, so I mentioned that the keys can be any data type. So you could have a string as a key, you can have whatever you want as a key. But under the covers, those keys are being converted to integers. One common way of backing a hash table is to use an array. And of course, for an array, you've got to have integer indices. And so to convert the keys to integers, you hash the key. And this is a process known as hashing. And so hashing maps keys of any data type to an integer. And so essentially, a hash function maps keys to int. Now in Java, the hash function is hash code, and the object class has a hash code method. And so every object in the JDK has this hash code method. Of course, you can override it, and it is often overridden. Now, it's possible that the hashing method may produce the same integer for more than one value. And when that happens, it's known as a collision. So in our case, let's say, as I mentioned, we're going to use the last name of our employee as the key. Well, if we have more than one employee with the last name Jones, then when we go to add Jane Jones to the hash table, Jones will be hashed to an integer. And if we went to add Mike Jones to the hash table, Jones will be hashed to an integer, and they're going to get the same result. So their hashed key values are going to be the same integer. And when that happens, it's known as a collision. And there are strategies for dealing with collisions, and we'll look at those later on. So some of examples of keys and values would be product numbers and products. So you'd have the product number as the key and the product as the value. Now you might be saying, well, if the product number is an integer, why would we have to hash it? Well, you may only have 10 product numbers, and that correspond to barcode values, for example. And so, you may only have 10 distinct products for your business, but the product IDs are things like 58298754. Obviously, you're not going to use that as an array index, so you're going to have to somehow hash those values to array indices 0 to 9. Employee IDs and employee objects, that's another possible key value pair that we could use rather than using the last name as the key. Usernames and profiles. When you create an account at a website and you provide a username, that under the covers may be getting hashed to an integer, and that integer is what's used to look up your profile. And of course, there's many, many more examples. Now, one important value for hash tables is the load factor. The load factor tells us how full a hash table is. So let's say we're backing the hash table with an array. The load factor would tell us how full the array is. And we can get that by dividing the number of items by the capacity, which is essentially the size over the capacity. So if we had an array of 10 backing our hash table and we had 5 employees currently in the hash table, the load factor would be 0.5. So that tells us that our array is half full. So the load factor is used to decide when to resize the array backing the hash table. I'm using an array as an example. Now, it's kind of a balancing act. We don't want the load factor to be too low because that means there's lots of empty space, right? I mean, if your load factor is 0.1, it means that only 10% of your array is occupied. But we don't want it to be too high because that will increase the likelihood of collisions. If most of the array is full and you keep adding items, you are going to get collisions eventually because you're basically hashing the keys to a range of values, essentially the valid indices in the array. And so if your array is already pretty full and you're going to be adding lots more items, you're going to start to get collisions. So to add to a hash table backed by an array, we would provide the key value pair, and then we would use a hash function, or in Java's case, we'd say a hash method, to hash the key to an int value. So let's say we want to add Jane Jones and we provide the key Jones. We would have a hash function that hashes Jones to an int value, and then we would store Jane Jones at the hashed key value. And so if Jones hashed to the integer 4, we would store Jane Jones at index 4 in the array that's backing the hash table. Now, when we wanted to retrieve the employee with the key Jones, we would provide the key, and obviously it's got to be the same key you used when you added the object, or it's not going to work. And then we're going to hash the key again, and obviously you have to use the same hash function that you're using to add values, otherwise it's not going to work. And so we'll provide the key Jones, we'll use the same hash function to hash the key to an int value, and we would get 4, and then we'd go and get the item that's stored at position 4 in the array. Now, if by any chance we'd had collisions, of course, we'd have to search through all the items. In that case, our array would probably contain a linked list, or it would contain each item in the array would be another array. And so we'd have to search through. As I said, we're going to see later how to handle collisions. So we'll see some of the ways that, some of the strategies for dealing with collisions and how we can store items that have the same hash key value. So as I just went through, if we wanted to add Jane Jones with the key of Jones, we use a hash function to map Jones to an int, and we'll assume we get the value 4, and that we'd store Jane Jones at array 4. And then to get the employee with the key Jones, we'd provide the key, we use the same hash function to map Jones to an int, and we should get 4 because we're using the same hash function, and so we just go to array index 4, and that would get us Jane Jones back. And that's how hash tables work. So let's move on, and as usual, we're going to implement a simple hash table. I'll see you in the next video.